Hi, I'm Tim Berglund with Confluent. From the earliest days of the cloud, we've been promised elasticity, the ability to add capacity when you need it and not pay for it until you do. Actually making this happen is a lot harder than it sounds, but I want to show you how Confluent Platform will make it easy in 3 different ways. First, we'll look at tiered storage, which gets you effectively infinite storage of data in Kafka topics at low cost. Then I'm going to show you a feature called self-balancing clusters, which allows Confluent Platform clusters to be scaled out while keeping partitions balanced between brokers automatically. And at the same time, I'm going to grow the disk space available on those brokers using a single command line command. These features aren't shipping in Confluent Platform at the time of this recording, but they're not far in the future, and you should start planning for them now. Before I show any of this happening, I feel like I should explain my demo environment. I'm running Confluent Platform in Kubernetes in my cloud provider's managed Kubernetes service. We can see some of the pods I've got running. There's one for Confluent Operator, which is a part of Confluent Platform and is a large part of what makes all this magic possible. I've got 3 healthy Zookeeper pods. And we've got a blob storage bucket, which you can see is empty, but it won't be for long. Now, I've got Confluent's Helm charts downloaded locally, which we used to deploy Zookeeper to the Kubernetes cluster before this demo. Now let's deploy Kafka. I'm giving it the path to my configuration file, which contains the config for Kafka, but also for Operator, Zookeeper, Kafka Connect, Replicator, Schema Registry, Control Center, and KSQL DB, all the gang. By saying Kafka.enabled equals true there, we're telling Helm just to deploy Kafka. Now, if we take a look at our workloads, we'll see that all 3 Kafka pods are running. Looks like the processes are still stabilizing, so we'll give them a minute, and there we are. They're up. And you'll note that each of our brokers is starting with 24 gigs of disk space. That'll be important later on. Now let's install Control Center and get it a domain name for our own convenience, and there, it's up. On the overview page, we can see all 3 of our brokers. You can drill down into any broker to see its aggregate rate of production and consumption, which are very small right now. You'll also note disk and network utilization are low for now. Finally, a quick look at topics in the cluster, and you can see that we don't have any yet. So that's Confluent Platform all set up and running in Kubernetes, hosted by our cloud provider, and ready for action. Now then, tiered storage. When you start to think about Kafka deeply, you realize there are powerful reasons for keeping a lot of events stored in topics over a long period of time. Deciding on a retention period is a complex matter, but being able to reason about more event history is generally better than less. The thing is, this gets expensive. You could pack a lot of disk on a broker, as we'll see in a minute, but persistent volumes attached to cloud instances are not the cheapest hosted storage you'll ever find. You'd rather put older data in a cloud blob store like AWS S3 or Google Cloud Storage. Tiered storage lets you do just that. You can configure brokers to keep a hot set of data locally on local disk and move older data to a second tier in the appropriate blob store. That data is still available transparently to Kafka clients to be read at any point later on. To see this work, we'll need some test data. We'll run the Kafka producer perf test tool against a topic called, appropriately, Elastic. We'll start that up using kube control and set it to generate 32 megabytes per second of traffic and just let it run. After letting it go for a little and checking back in Control Center, we can see that our topic has been created and it has 48 partitions.
And at this point, it looks like disk utilization has gone from near 0 to a little under 3 gigs per broker. And it's pretty even across the brokers, which is good. And that bucket we wanted to put the older data in, that cloud storage bucket, you can see it's been initialized, but those folders don't have a lot of content yet since tiered storage hasn't really kicked in.
Of course, if we keep this running at 32 megabytes per second coming into the topic, eventually we'll hit the threshold where the brokers have enough data stored on them and they'll start to move older records into the blob store tier, which is exactly what's happening now. I sped this up a little bit to keep it from becoming tedious.
Now you can see there's a good 16 gigabytes of data in the tiered storage bucket, and disk utilization in the brokers has plateaued.
For any new data coming in, they'll push older data out to the blob store. It's effectively infinite. And very, very elastic storage is key, but we also need to be able to scale our Kafka cluster horizontally and vertically. Now, Kafka has always been able to scale horizontally, but one might not have always described the process as being particularly elastic. What I'm going to show you next is. And even so, horizontal scale isn't the answer to every question. Sometimes what you need is simply more disk space on the brokers you've got. I'm going to show you both of these things happening together. Horizontal scale out and what we call parallel disk expansion, or scale up of local disk. Right now, our cluster still has 3 nodes, and each node has 24 gigabytes of disk. I'm going to scale out and up at the same time, so I'll update my configuration to say that I want 12 brokers, not 3, with 240 gigabytes of disk space each, not 24. I'll rerun Helm, and the first thing that happens is that the cloud provider's Kubernetes console says the additional brokers are unschedulable. This is because we don't yet have enough Kubernetes nodes to schedule the additional brokers. However, GKE, which is my managed Kubernetes provider in this case, sees that and will schedule the additional nodes, and soon we'll be able to auto-scale to give us what we need. Sure enough, not much later, we're up to 16 nodes, and the new brokers are now scheduled. Also, notice the disks. We used to have 3 24 gig disks, but now we have 12 240 gigabyte disks instead. So we've scaled out, we've added 9 brokers, and up. We've added 10 times the disk space on each broker. Now again, we've always been able to scale out a Kafka cluster. This is not new, but there was never a guarantee that data would stay balanced after the scale out. In fact, it probably wouldn't. Remember that each broker is responsible for some number of partitions, which are ultimately what? They're log files on disk. When we increase the number of brokers, those partitions don't move magically to the new brokers. That rebalancing is a thing that happens automatically when you're running Confluent Platform, thanks to this new feature we're working on called self-balancing clusters. And after a little bit, you can see that disk utilization has evened out across all our brokers. If you recall, we had 3 brokers with like 15 to 20 gigs of disk used on each, and then we added 9 more brokers which had 0 disk utilization initially. And now, not only the one topic that we created with our test, but also the 40-ish internal topics that Confluent Platform uses have all been rebalanced, and we have a fairly even distribution of disk utilization across the brokers. And you can absolutely script this kind of thing yourself, right? I mean, Kafka's administrative tools let you move partitions around a cluster, but this kind of thing is not trivial to get right. And managing it is almost certainly not the business you're in. It's vastly preferable to have a cluster that does this automatically, which is yet another thing Confluent Platform does for you. So let me remind you of what we've seen. We saw tiered storage happen, in which older records got automatically written to the cloud blob store of our choice, while remaining fully and transparently readable by all Kafka clients. We saw a downright easy way to scale out a cluster to more brokers and have its data rebalanced automatically between those new brokers. Finally, we scaled up the nodes of that same cluster at the same time as we scaled out, increasing their disk space by 10x with a single config change. All of these things are coming soon to Confluent Platform as we work to bring the long-awaited promise of elasticity to your deployment of Kafka. Check it out soon.